So this is a demonstration of the single packet authorization technology with fwknop running in the Amazon cloud. So first I'm going to log into the AWS management console. You can see I'm logged in as me. And I have one VPC network set up within Amazon right now, Amazon's cloud. And there is, as you can see, one VPC instance. I have one elastic IP assigned to that instance. There's one security group and two running instances. These are EC2 instances within the Amazon cloud. So I'm going to take a look at what those instances are so you can see what is set up currently. So there are two instances currently running. If I select this one, you can see that this is an Ubuntu Linux machine 12.04, and it is currently associated with a routable elastic IP within Amazon's network. It also has a private IP. It's displayed down here, but that's not important for this demonstration. The most important thing is that it has an externally addressable IP address. And if I select this IP and open this within a web browser, you can see I'm running a copy of my website on that particular Ubuntu host. I can reload the page, and this website is currently live. So switching back to the Amazon console view, I'm also running a Windows EC2 instance within the VPC network. This Windows instance has a non-routable IP assigned here, 10.0.0.132. You can see that this is a Windows Server 2008. And for emphasis, again, it has no elastic IP assigned. It cannot be addressed directly from the internet without going through special measures. Switching back over to the VPC view, let's take a look at the security group. So the security group defined for this VPC network is very restrictive. There are only two services that are allowed at all: HTTP and UDP port 40001, which happens to be the port that I'm going to send all of the SPA packets over. And again, of course, they're never going to be acknowledged from the server side. This is a totally passive authentication scheme, except for the client. It has to send some data. And once again, for emphasis, web server is still running, of course. Now I'm going to minimize the browser. And here now we have a setup that allows SPA to function. First, this system named Rohan has its own IP address that is independent of the other three windows. All the host names in these windows are Lorien, as you can see. So this Rohan host represents just an arbitrary host out on the internet that may try to observe what's happening on the EC2 instance. So I'm going to scan that host, not really heavily scan it. I'm just going to look for whether or not port 80, port 22, and port 3389, which is the RDP port, is currently available on that host. Once I scan it, you can see that port 22 is filtered along with port 3389 also being filtered. This is because of that policy deployed in the Amazon cloud, but port 80 is open because the website is available. In addition, I'm going to scan port 40001 just to see what it says, UDP. And of course, UDP being under no obligation to respond with anything at all, it happens to be filtered because it didn't get any response back from the probe that mmap sent. So now I'm going to launch a watch window, and I'm going to use version detection against port 80 on that system. And then down from the host called Lorien, where I'm going to run all the SPA packets from, I'm also going to run the same mmap scan. So from 2 different hosts on the internet, we're going to see what Apache or what service is bound to port 80, and in both cases, mmap reports that Apache HTTPD 2.2.22 is running on the Amazon EC2 IP here. Okay, fair enough. So let's now switch to gaining some additional access through port 80. In this case, what we're going to do is we're going to instruct the fwknop client to communicate with the fwknop server over port 40,001 and request access to TCP 80 on the Amazon EC2 instance, which with this IP, which is again bound to that internal Ubuntu host. And we're going to use the SSH client over port 80 to gain access to that host. So now I have access. I've just logged in over SSH. Notice that Nmap is currently reporting from this IP only that OpenSSH is actually running, whereas the arbitrary host out on the internet still always only ever sees the Apache web server. But I have access to the EC2 instance. And the fwknop daemon has timed out the accept rule for my NATed SSH connection over port 80. And so it has switched back to, because that rule was deleted, now it has switched back to apparently a web server. We can again load the page just to verify that, and yes, it is back to a web server. But note that I still have my SSH connection open because I'm using the connection tracking capabilities in the IP tables firewall to maintain the connection in the established state. And here is just a little watch window again. This is running fwknopd in fwlist mode, so I can see all of the rules that it adds to any of the fwknop created chains. And now I'm going to do something a little bit more interesting, which is to gain access not to SSH on the EC2 network, but gain access to RDP on the Windows host through the Ubuntu host. Again, through port 80. Note that both of our scanners are currently only seeing Apache. But now I'm going to run this script, which is going to say, again, gain access to TCP through TCP port 80. I'm going to send the SPA packet over port 40,001. And this time I'm going to run it in NAT mode and request access to port 3389 on this host, which is the Windows host, on the externally routable elastic IP that we are currently working with. So in this case, now you can see that an RDP window has popped up. At the same time, this rules listing is showing that I've got some additional NAT rules created, which is how the RDP connection is able to be sent through the Ubuntu host. I'm going to log in here. Notice that our scanner shows currently that port 80 is filtered. I'm not sure if that's perhaps a limitation on the Windows side, not being able to handle multiple RDP connections simultaneously very easily or something. Not sure what's going on there, but again, the external non-affiliated host always only ever sees Apache. But as you can see, I have not only an active RDP connection into that Windows host, but I also still have my SSH connection open. And confirming once again, just for illustration on the web side, I can reload this page, and yes, it's still a web server. Okay. I'm going to leave these two connections up. Now I'm going to do a replay attack against the fwknop daemon. In this case, I'm going to run the SBA, the fwknop command again, but I'm going to capture using script all the output. And this little Perl invocation here that you're seeing is just so that you can't see my home network IP. Hope you don't mind. And for now, what I'm going to do is you can see that my SSH connection is still active here. I'm going to run the RDP. I'm going to run the verbose command again. Note that I do have access, so I have two simultaneous SSH connections going here. I'm still running that list command in this one, so I have one connection open here and another connection open here. I'm going to log out of this connection, so this one's no longer active. I'm back on my local Linux machine. This one is still active. Now, since I ran the fwknop client in verbose mode and captured its output, this is the raw SPA packet data that's sent over the wire. So I'm going to replay this data with netcat over a UDP socket to the EC2 instance. Note that the list command is still running, but I don't have any new rules being created. So if I exit out of that and look at the so you can see that fwknopd has detected a replay attack from IP 123.2.3.4. That's just what my little Perl invocation is changing my home IP to, but you can see that the replay was detected and no access was granted. But again, my SSH connection is still active, and so is my RDP connection into the Windows host, but all that the simulated user out on the internet ever sees is Apache. They never saw SSH or RDP or anything of the sort. They're only seeing Apache, and even my system where I'm sending the SPA packets from to has switched back to Apache 2. And if I reload this, web page is still active. That concludes the demo.